Well, in the for what it's worth department, with functions of more than one variable, the limit will not exist at a point if the limit is different on different paths. Now that's different from what you're used to seeing.
I can't wait.
Well, I was going to say, and now I'm going to show you this, and I hope it'll be exciting.
I can't wait.
Well, that's good. So show that the limit does not exist at 0, 0. Well, if you just plug in 0, 0, you get 0 over 0, but as we saw in Calculus 1, that doesn't mean a limit doesn't exist. So if we move along the path y equals 0, then the limit is 0 over x squared plus 0. I mean, if y equals 0, it didn't say x was 0 necessarily, so we'd still have 0 over a number, which is 0. But if we moved along the path where y equals x, we'd replace x here and here. And we would have x over x squared plus x squared. In other words, we have limit as xy goes to 0, 0 of x over 2x squared. Well, cancel this x with one of these x's, and we have 1 over 2x. As x goes to 0, that's 1 over 0, which is infinity. So, wow. One path we get 0, one path we get infinity, so that function clearly doesn't have a limit at 0, 0 because you get two different numbers on two different paths. That's a little bit like this kind of a limit. As x goes to 0 from the right, we have, that means it's a positive number, we have a positive over a positive, and that gives us 1. But if we go to 0 from the left, we have a negative over a positive, which is -1. So this limit, my graphing software isn't all that good. It really should show like a hole here and a hole here and nothing in between instead of drawing that red line on the axis. But it just connects dots, and I can't get it not to do that. So that is a clear picture of a graph whose limit doesn't exist at 0. Now, what about this one we just looked at? Well, here's the story on this one. Y equals x would be this line going up here like this. And y equals 0 is this line right here. And if we looked at the limit as y equals 0, we come over to 0 on that path. There's probably a little grid line in there at 0, and it just comes over to 0, no problem. But if we look on the line y equals x, when we get to 0, 0, we have this huge peak. And by the way, that would be if x was going to 0 from the right, then we have a 0 over a positive, sorry, a 1 over a positive number close to 0. So it would be positive infinity. If we were going to 0 from the left, then we'd be down here at this point, negative infinity. So that's an example of a function that clearly has no limit depending on the different paths you get to the point 0, 0. So in some ways it could be 0, in some ways it could be, believe it or not, infinity or even negative infinity. So that's kind of wild and crazy.
Nice work.
Thank you.